Now see this example where we need to convert this NFA to DFA and then find minimal finite automata. Let me start with the first process, that is conversion from this NFA to DFA. We all remember I have already described the concept of subset construction in my previous video. Here we have subset construction. There are three states, 1, 2 and 3. Start with 1, the initial state. The symbols are A and B. 1 on reading A is going to state 1 as well as 2. So we get a subset 1, 2. 1 on reading B is going to state 1. We have new state here, subset here 1, 2. Take 1, 2. 1, 2 on reading A. So I'll write it in this way. So find out the transition of 1 on reading A. It is 1, 2 union with 2 on reading A. 2 doesn't have any transition for A, so it is 5. So I get 1, 2 only. This is equal to 1, 2. So 1, 2 on reading A is giving us state 1, 2. 1, 2 on reading B see the diagram, 1 on reading B is going to state 1, 2 on reading B is going to state 3, so I'll get the output 1, 3. I get 1, 3. 1, 3 is a new subset here, so I will again expand this 1, 3 and we'll repeat the process for 1, 3 on reading A. So I'll write it here, delta 1, 3 for A is delta 1 on reading A union with delta 3 on reading A. 1 on reading A is going to state 1 and 2 union with 3 on reading A state 3. So I'll get the output 1, 2, 3. New subset 1, 2, 3. Again 1, 3 on reading B. 1 on reading B union with 1 on 3 on reading B. 1 on reading B is going to state 1. Union 3 on reading B is going to state 3. So I'll get 1, 3 only. So for this I get 1, 3. Now I'll repeat the process for the state 1, 2 and 3 because this is one of the new subset generated here. Delta 1, 2, 3 on reading A is delta 1 on reading A union with delta, 2 on reading A union with delta, 3 on reading A. Now see the diagram. 1 on reading A is going to state 1 and 2. 2 on reading A is 5. 3 on reading A is 3. So I'll get 1, 2, 3 only. Now repeat the process for the symbol B. 1 on reading A union B, 2 on reading B, 3 on reading B. 1 on reading B is going to state 1, 2 on reading B is going to state 3, 3 on reading B is also going to state 3, so I get the output 1, 3. So the two outputs are 1, 2, 3 and 1, 3, and we are not getting any new subset here, so the generation of the table will stop the generation here only, and then we'll make the diagram for the DFA or the corresponding table. So I'll write this 1, 2, 3. On reading A, I get 1, 2, 3. And on reading B, I get 1, 3. Now make the diagram. Starting state is 1. 1 on reading A is going to a state 1, 2. 1 on reading B is on the same state. 1, 2 on reading A stays there only. 1, 2 on reading B is going to a new state 1, 3. Now 1, 3 on reading A is going to a new state 1, 2, 3. One, 3 on reading B stays on the same state. 1, 2, 3 on reading A is going to state 1, 2, 3 only. So this is the loop. 1, 2, 3 on reading B is going to state 1, 3. So now this is the diagram, but we have to make the accepting state. What was the accepting state in the original diagram? 3 state. 3 is the accepting state. Now look for all those states where 3 is there. So here we have in 1, 3, 3 is there. So I'll make this as an accepting state. 1, 2, 3 also has 3. So therefore this is an accepting state. So the diagram is completed for DFA. Now this is the DFA for the given NFA. Now what we need to do, we will check whether this DFA is in the minimal form or not. If it is not, we have to convert into a minimal DFA. Let me start with making the table. Now what I will do, for the simplicity, I'll rename these states into 1, 2, 3 and 4. So this one, I'll rename the first one as 1. This one, 1, 2 state is renamed as 2. Sorry, this is A. One 3 state is named as 3. 1, 2, 3 state is named as 4. Just for simplicity, I have renamed into 1, 2, 3, 4. And now I will be minimizing this automata to form the minimal form. So 1, 2, 3, 2, 3 and 4. So let me start with the phase 1. Check for all those pair of states where one of the state is an accepting state and the another one is not a accepting state. So in phase 1, I'll keep on checking the pairs. Start with this place 2, 1. 2, 1 is not marked because neither 2 nor 1 are the accepting state. So next 3, 1, 3, 2. 3, 1, 3, 2 are marked because 3 is an accepting state, 1 is not accepting, 3 is an accepting state, 2 is not accepting. So I will mark this 3, 1 and 3, 2 cells are marked in phase 1. So I'm putting the value 1. Now in 4, 1, 4, check for 4, 1, 4, 2, 4, 3. 4 is an accepting state, 1 is not an accepting state, so I'll mark it. 4, 2, 4 is an accepting state and 2 is not an accepting state, so again I'll mark it. 4, 3, both of these are accepting, so these are not marked here. Let me go to this phase 2. In phase 2, we'll check for the state 2, 1. Now delta 2 on transition of A, 2 on transition of 2 on reading A. Similarly, transition of 1 on reading A. See the main diagram. 2 on reading A stays on 2 and 1 on reading A is going to state 2. So we got what? 2, 2. Check for the another symbol, that is 2 on reading B and 1 on reading B. 2 on reading B is going to state 3. 1 on reading B is going to state 1. We are getting the pair 3, 1. 3, 1. 3, 1 is an already marked. 3, 1 is already marked. So therefore, I'll mark this 2, 1 in the state. Here we have 2, 1. Now check for 4, 3. 4 on reading A is going to state 4 and 3 on reading A is going to state 4. Again check for symbol B, then 4 on reading B is going to state 3 and 4 on reading 3 on reading B is going to state 3 on reading B is going to state 3. Now see that we have the output value 4433, which is never found in the table. So this cell 43 is never going to be marked in any of the phase. So we will stop the process of making table and will make the minimal finite automata. For that, check the unmarked cell. Where this unmarked cell is? This place is an unmarked cell. This one. And this cell is 4 and this cell is 3. So these two are going to be merged. So let me do that. I'll make one state P1 and I'll merge the state 3 and 3 with 4. And we'll make the diagram. Start with the state 1. 1 on reading B is on 1. 1 on reading A is going to state 2. 2 on reading A stays on 2. 2 on reading B is going to state 3. Where is 3 currently? 3 is with state P1. Okay. Now P1 on reading A. P1 on reading A. P1 is state 3 and 4. See the transition of 3 and 4 in the main diagram. 3 on reading A is going to state 4. Where is 4? 4 is in P1. Similarly, 4 on reading A is going to state 4. So P1 on reading A stays on P1. Similarly, P1 on reading B. So see the transition of 3 and 4 on reading B. 3 on reading B is going to state 3 on 3. 3 is in P1 only. 4 on reading B is going to state 3. It is also there, that is on P1 only. So therefore P1 on reading B stays on P1. So this is the final DFA for the given NFA. Start with this. This was the original NFA. We converted this into this DFA, and this DFA was minimized to find the minimal DFA. So this is the minimal DFA. Okay, now in this diagram, we need to put the final state. Which one is the final state? See the DFA, this DFA, 3 and 4. The state 3 and 4 are the final, that is accepting state in this diagram. So P1 has state 3 and 4. So P1 becomes the final state of this minimal finite automata. Hopefully this example is clear to all of you. Thank you so much for watching.